Day 7 of our unit on circles. And we will continue our exploration of the relationships between the angles that you can make with circles and the arcs that they intercept. Now here's the overview. The first two circles represent what we've been talking about during the last few lessons. And then the second two circles represent new material. So just a quick review. First we learned about the relationship when the vertex of an angle is at the center, like angle theta here. And we learned that the angle and the arc are the same. Like if this is 30 degrees, the arc is 30 degrees. Then we learned about, and that was called a central angle. Angles like this pink angle here are called inscribed angles. Angles with a vertex on the circle. And we learned that the angle and the arc measure are not the same. The angle is smaller. Specifically, the angle is half the size of the arc. Or you could think of it as the arc is double the size of the angle. So if the angle were 30 degrees, the arc measure would be 60 degrees. So, vertex at the center, vertex on the edge of the circle. That just left two other possibilities. What if the vertex is not at the center, but it's not all the way to the edge either? What if the vertex is somewhere floating inside the circle, but not on the center? And it also left the possibility of what if the vertex is completely outside the circle? So rather than just drawing a single angle, for the rest of these cases, we need to go ahead and show a pair of vertical angles. Obviously the angles are the same, but these angle relationships involve more than one arc. So we have to go ahead and draw these intersecting lines and deal with the vertical angles here. So what we find is, in the case where the vertex is inside the circle but not at the center, technically this actually would still work if it were the center. But the situation is basically the angle measure is the average of the two arcs. So just to be clear, the two arcs that I'm talking about are these arcs right here. So this is one arc, and this is the other arc. Okay, so this angle right here is going to be the average of these two arcs. So the angle is the one arc plus the other arc divided by 2. Now when the angle is outside of the circle, you can find that angle still using these two arcs, but it's slightly different. Instead of adding them up and dividing them by 2 like you do when you're taking the average, you will subtract them and divide by 2. So just be careful that when you do the subtraction, you want to do the bigger arc minus the smaller arc divided by 2. So that's how you find the angle when the vertex is outside the circle. So really that covers all the possibilities. You're either at the center, on the edge of the circle, or you're floating inside the circle somewhere randomly, or you're completely outside of the circle. So now we've covered all 4 possible cases. Notice you are not likely to be given these formulas, so you need to memorize them. All right, armed with this knowledge, let's go ahead and do some problems. Oh yeah, wait, one more thing. One more thing that we need to introduce is the concept of what happens with tangents. So I just need you to understand, looking at problem number 1, for example, if you look at this angle right here, the one that's 101 degrees. Yeah, if you look at this angle, I want you to notice that this is still an inscribed angle. See the vertex right here? See how the vertex is on the circle? That is a special case. Even though one side of the angle is a tangent, it works just as well as if this side of the angle were inside of the circle and we were talking about this angle right here. Okay, if it were an angle like this, we would automatically know, oh yeah, well this arc is going to be double this angle is going to be half the arc. Guess what? It still works when it's a tangent. Just treat this like any other inscribed angle. So the arc that goes with this angle is going to be this arc right here. All right, this is the arc that belongs to this angle. Okay, so an inscribed angle, remember the arc should be double the angle. So if the angle is 101, that means the arc is going to be 202 degrees. Well, that's a lot of ink. Now, what are we being asked to find though? We are being asked to find the measure of arc AB. Is this arc AB? From here to here, is that arc AB? Well, no. Remember, if you're just given two letters like this, this has to be a minor arc because it's only two letters. So this guy must be a minor arc. Meaning it's got to be less than 180. It's got to be less than 180. This is 202 degrees. So I don't know why they put this dot C out there. Really, I feel like they should have put that over here. So anyway, the point is arc AB has to be a minor arc. So it really has to be the one that's over in this area, like so. Okay, it's really the blue arc that we're being asked to find. So this is arc AB. Okay, so if I want to find that, I need to subtract from 360. So I'm just going to do 360 minus 202. And that should give me my final answer. So that is 158 degrees. So that is the measure of arc AB. Okay, in this lesson, I think, no, I'm doing them all. All right, 1 through 19. Very good. So moving on to number 2. Now that you see the idea, remember the arc should be double the angle. Then look, first of all, this 129 degree angle, maybe I'll do it the other way. We are being asked to find arc FH. So let's start with that. Let me go back to my previous system of marking in red whatever it is I'm trying to find. So we are trying to find that arc right there. So if I want to find that arc, okay, let me just put a little question mark there, arc FH. I could find that arc if I knew this angle over here. Let me trace that for you. All right, if I knew this green angle, well then the arc would just be double that. So let's find the green angle. Well, the 129 degrees can help me find this green angle. Can you see how? Well, look at this orange line that I've highlighted. This is a straight line. That means if I look at these two angles that make up this straight line, they have to be supplementary. This is the total of these two angles has to be 180 degrees. So I can just subtract from 180. So if we just do that, if we just go ahead and do 180 minus 129, that should give me the green angle. And that is 51 degrees. So that tells me that the green angle here is 51 degrees. So let me just put a little arrow. Okay, so that is 51 degrees. So that means the arc should be double that. So that should be 102. So can get rid of the question mark and go ahead and answer the question. So this should be 102 degrees. Okay, and I got that just by doubling this. Alright, but anyway, that's it. That's how you do that. Okay, moving on to number 3. Remember what I did before with that orange line over there. Here again, this line represents a total of 180 degrees. Just like I could draw a semicircle right here. So that means that these 3 angles have to add up to 180 degrees. And you can see by these red markings that they are all congruent. So I can just go ahead and do 180 divided by 3, just like this. And that should give me each of these 3 angles. Okay, so clearly that's going to be 60. So each of these angles are 60. So this is 60, 60, and 60. So keep that in your brain. Now, what are we being asked to find? Arc Jkl. So Arc Jkl goes like this. Alright, starts here at J, and here's Arc Jkl. It starts at J, goes through K, and goes around to L. Okay, I've shown here in red Arc Jkl. So that arc is only covered by 2 of these angles. In other words, this green angle is the angle that captures that arc. So again, this green angle is an inscribed angle with vertex on the circle. So the relationship is the arc should be double the angle. So looking at this 60 and 60 right here, hopefully it's clear to you that this angle, this green angle, is 120 because of the 2 60s. Alright, so this green angle that goes like from here to here is 120. So if I want to find the red arc, I have to double it. So this should be 240 degrees. Okay, it's just 120 times 2. Okay, so that's number 3. So what's next? Let's look at number 4. Alright, number 4. We're supposed to find the measure of angle 1. And there's 2 ways I can do it. I could take half of this big arc out here, and that's going to give me this angle. Then I could subtract from 180. Or I could subtract 248 from 360 and find this arc over here, and then half of that arc should give me the angle. I'm not sure which way is simpler. I mean, really, they're both exactly the same. I'm going to do the second thing I said. We're trying to get over to angle 1. So if to find angle 1, it would be helpful to know the arc that's intercepted by that particular angle. So if I want to find that arc over there, I will subtract from 360. So if I do 360 minus 248, okay, that's going to give me this arc right here. Alright, so that's going to give me this arc right there. So that is 112 degrees. So if I want to find the angle 1, which is like this angle that's going like this, angle 1, I'm just going to divide by 2. The angle should be half of this arc. Okay, so this angle right here, I'll just put a little arrow to it, should be, okay, half of this is going to be 56. Alright, that's number 4. Now number 5. Okay, now we're back up to that the new situation where you have to look at two intercepted arcs to do this. So the angle is going to be the average of the two arcs. So angle equals arc plus arc divided by 2. Keep that in your brain. So we're supposed to find this angle right here. Okay, so I hope you don't mind. I'm going to go ahead and put a theta right there. That's what I'm trying to find. The two arcs that go with this are this arc and this arc right here. So just like the formula said, the angle should equal arc plus arc divided by 2. So 116 plus 140 divided by 2. So it's, if you know the formula, it's pretty straightforward. So 116 plus 140 divided by 2. So that is 128 degrees. Kabam! That's number 5. Number 6. Now, notice this one, the angle is outside the circle. So we're going to be using this formula. The big arc minus the small arc divided by 2. You just have to memorize these formulas. So the angle, and again, the angle, I always use theta when it's a variable. So the angle is going to equal the big arc minus the small arc divided by 2. So that's 37. Pretty straightforward, if you ask me. Will they all be that straightforward? Sadly, no. Let's see how it keeps going. So number 7. So we have a couple tangents here, but that doesn't bother us. We see that's kind of intercepting right there. But oh wait, Mr. Burton, I see that this is outside the circle. So I know I'm going to be using this arc minus arc divided by 2 formula to get the angle. But they only gave me one arc. So what am I supposed to do, Mr. Burton? Well, this is what you do. You subtract from 360, of course. This circle, as shown here, is only made up of 2 arcs. So the 243 is that arc right there. But the other arc is this arc right here. Alright, those are the only 2 arcs. So you can just subtract from 360. So this arc is 117 degrees. So now I'm back in business. And again, I'm going to call that angle theta. But the angle is going to equal the big arc minus the small arc divided by 2. Okay, and that's going to give me 63. Okay, look at number 8. Alright, well this one is pretty straightforward. This is back in the situation where we are doing the average of the 2 arcs, arc plus arc divided by 2. So that's pretty straightforward. So the angle is going to equal the arc plus the other arc divided by 2. That is 109 degrees. Okay, number 9. This one we have to be a little bit careful because this angle out here is not the right angle that goes with these 2 arcs. Is it? Because, you know, like looking at these 2 arcs here and here, the angle that intercepts them is the angle that's in here, not the angle that's angle 1. So what I'm going to have to do is, if I want to find this angle, First, I'm going to find the normal angle that we're used to. I'm just going to put a, I need a new variable. Alright, I think I will use alpha for this angle that's in here. So there's alpha, sort of like that. So this angle, I'm going to use a normal formula like we've been doing. The angle should equal the arc plus the other arc divided by 2. But notice, to get my other angle, I'm going to have to subtract from 180 because it makes a straight line right here. We'll deal with that in a second. So anyway, this angle is going to equal 53 plus 41 divided by 2. Okay? So alpha equals 47 degrees. But that is not the final answer to the question. We're supposed to find angle number 1 up there, which I'm going to go ahead and call theta like I've been doing. But look at the relationship here. So this makes a straight line. Let me do this in orange. See this? I always do my straight lines in orange for some reason. That is a straight line. Okay, this, another way of looking at it is semicircle. Okay, this is a semicircle that goes like from here to here like this. So these two have to add up to 180 degrees. So if the one angle is 47, then I should be able to subtract from 180. So my other angle should equal 180 minus 47. So the angle I really want is 133 degrees. Alright, some kids have a hard time understanding why the answer is not 47. You know, so I'm hoping that you see that, just going back a couple steps, get rid of that for a second. I'm hoping that you see that when I have these two arcs that are lined up like this, the 53 and the 41, it almost makes a straight line between the 53 and the 41, and the angle that you need has to be the angle that's in the middle between them. So kind of like if I connect these up, okay, making that bow tie shape between the two arcs, it has to be the angle inside the bow tie. It can't be the angle that's outside. Anyway, moving on. Number 10. Okay, clearly this angle is outside the circle. So thing number 1, I'm going to be using this formula, arc minus arc divided by 2. Now, focusing on that aspect of it, the two arcs that I need are, one of them is going to be this arc right here. Alright, at the moment I don't have that, so I'm going to need that. But the other arc is this arc out here, which I do have. Okay, those are the two arcs that I'm going to do a big arc minus small arc with. So to be able to do that, I need the green arc. Now, luckily, this circle is only made up of 3 arcs. It's got the 174, the 119, and the missing arc that I need here in green. So, I'm just going to draw an arrow there. Obviously, I can just subtract from 360. So subtract 174 and 119 from 360. That is 67 degrees. So now I can do my thing. Okay, I'm going to call that theta like I have been doing. So now I can go ahead and say the angle is going to equal the big arc minus the small arc divided by 2. So that is 26 degrees. Okay. Let's see, number 1 is similar to problems that we've just done. Again, this angle is outside the circle, so I'm still using this formula right here. The two arcs that I need are this arc here. This is the big arc. And I need this arc right here. This is my small arc. Okay, I have the small arc. To get the bigger arc, I just will subtract from 360. So that's 222 degrees. Now I can go ahead and do the formula. So I'm going to call this theta again. So the angle will equal the big arc minus the small arc divided by 2. So that is 42 degrees. All right, number 12. Same type of thing. The angle is outside the circle, so I'm still doing the arc minus arc thing. The two arcs that I need are this arc right here and this arc right here. I have the red arc, I need the green arc. I have everything else, so I can just subtract all of these from 360 and find the green arc. That's 41 degrees, so I got 41 degrees. Now I can go ahead and do my thing. Alright, so the angle is going to equal the bigger arc minus the smaller arc divided by 2. That's a 2, not a z. I always do that. And that is 35 degrees. So that's number 12. Okay, let's find number 13. And there it is. Okay, we got to find the value of x. Okay, so x is this arc here. So we got the arc. We have this arc and this arc right here. But understand, like we were talking about before, this 129 is the wrong angle. It is outside of the bow tie. See what I'm saying? Okay, the arcs and angles here. I really need this angle that's inside. So again, because of a straight line, looking at this straight line right here, it's well, it's not a diameter, but still, these two angles have to add up to 180 degrees. So let us subtract from 180 to figure out what this theta here really is. So that turns out to be 51 degrees. So we're gonna use the 51 as the angle, not the 129. It has to be between the two arcs, inside the bow tie, if you will. Anyway, be careful with the formula. We're dealing with this one. Angle equals arc plus arc divided by 2. All right, remember that setup. Angle. The angle is what we're sort of starting with here. So when I do that formula, okay, if you remember that I'm doing angle equals arc plus arc divided by 2. Man, my 2's look like these. The x and the 35, those are not angles. That's the arc and the arc. The 51 is the angle. So the 51 has to go right here. So when I set up my equation, I'm going to start with the 51. A lot of kids always want to put the variable here by itself automatically. You can't do that. You can't just go x equals 51 plus 35 divided by 2. That would be wrong. Alright, this has to be the angle, and these have to be the arcs. So the angle is 51, x and 35 are the arcs, so it has to be x plus 35, arc plus arc divided by 2. So then it's just a matter of solving this equation for x, and I recommend multiplying both sides of this equation by 2 first. That gets rid of the fraction aspect of it. Alright, so then we're going to have 102 is equal to x plus 35. So then you can simply subtract 35 from both sides. And that's going to give you x equal 67. Okay, that is how you do that. So looking at number 14, same type of thing. So remember, the formula here is going to be angle equals arc minus arc divided by 2. So 24 is the angle. So 24 has to go here. So we're going to start this equation with 24 equals. Now this big arc minus small arc. So it's got to be 118 minus x divided by 2. Again, to solve this, simply multiply both sides of the equation by 2. These will cancel out. So that's going to give me 48 is equal to 118 minus x. I could subtract 118 from both sides. It's one way to do it. That's going to give me x equals negative 70. I'm sorry, it's not x equals. See that minus sign right there? That's negative x. Okay, so I'm going to have negative x equals negative 70. And if negative x equals negative 70, that means x equals 70. You can think of that as multiplying both sides by negative 1 or dividing both sides by negative 1. Okay, number 15. Alright, so again, in this problem we have to be very careful. Whoops. Because the angle that we're given, this 137, is not the right angle. Looking at these formulas, we're dealing with this one right here with the arc plus arc divided by 2. But if you look carefully, you will see that this angle is not the right angle that we need. Alright, these are the two arcs we're dealing with, the 25 and the x. Well, it's a little messy. So the angle that we needed was this angle right here. Okay, see how it has to line up with the arcs. This angle over here is off to the side, it's the wrong one. So use your straight line. If you look at it this way, whoa, that's big. Here's our straight line right here. So looking at that straight line, okay, that's being divided up into these two angles. These two angles have to add up to 180. So the best way to find this angle is to subtract from 180. So this should be 180 minus 137. Alright, so that's going to be 43. So I'm going to go ahead and just put that in here. So this angle is going to be 43. Alright, so this is the angle that we're going to use, not the 37. So we'll go ahead and do the formula. Remember that it is angle. The angle equals arc plus arc divided by 2. So when we set this up, this is going to be 43 equals x plus 25 divided by 2. And again, to solve this, you should just multiply both sides by 2. So those 2's are going to cancel each other out. So that's going to be 86 is equal to x plus 25. Subtract 25 from both sides, and that's going to be your answer. Okay, so that's going to be 61. Alright, that is how you do that. So that was number 15. Alright, 4 more problems to do. This seems like kind of a long assignment. Alright, looking at number 16, hopefully it's obvious to you that we're in this fourth situation with the angle going outside of the circle. So we're going to do angle equals arc minus arc divided by 2. So let's go ahead and set that up. So it's going to be just like this. We're doing angle equals arc minus arc divided by 2. So the angle is 61. So this is going to be 61 is equal to. Now we really have to do the big arc minus the small arc. So the big arc is 10x plus 1. And the smaller arc, so I've got to do minus, the smaller arc is the 5x minus 1 divided by 2. That's the equation. Now it's just a matter of solving this equation. Here's one thing you have to be careful of. Notice how I put these quantities in parentheses. Anytime you have a binomial or something like this, you should put it in parentheses because you have to remember to distribute this negative sign. So this is going to be like this. So we'll have 61. You know what? Let's go ahead and multiply by 2. Let's get rid of this fraction. So I'm going to go ahead and multiply by 2 on both sides. So these 2's are going to cancel each other out. So that's going to give me 122 on the left. So that's going to be 122 is equal to. Now let's go ahead and do the rest of this. So this will be 10x plus 1. Now I'm distributing the minus sign. So that's going to be minus 5x plus 1 because the negative of a negative is a positive. Alright, and the 2 is already gone because I canceled that out. Let's combine like terms. The 10x and the negative 5x are going to go together. And the positive 1 and the positive 1 are going to go together. So that's going to make 122 is equal to 5x, 10 minus 5, plus 2. Hopefully now it's looking really simple. So subtract 2, that's just going to be 120 is equal to 5x, and then divide by 5, and that should be your answer. So that was a little complicated. I'm hoping that you followed it anyway. Okay? So that's going to be 24. Alright, let's see what's left. Alright, 3 more problems. Well, this one's basically the same thing. Angle equals arc minus arc divided by 2. So this will really be the same thing. So this will be 39 is equal to 17x plus 6 minus 7x minus 2 divided by 2, just like last time. Just like last time, let's multiply both sides by 2. Okay, so that's going to give me 78 equals. Now again, be careful, this minus sign has to distribute. So this will be 17x plus 6 minus 7x plus 2. Negative times a negative is a positive. Combining like terms, 17x minus 7, that's 10x. 6 plus 2 is 8. Okay, subtract 8 from both sides. That's going to give us 70 equals 10x. And then just divide by 10. Alright, so x is 7. Alright, once again, number 18 is basically the same thing as the last 2 problems. So angle equals arc minus arc divided by 2. Now be careful that you do the big arc minus the small arc. So this 13x minus 16, this is the big arc out here. And the 5x plus 14, that's the small arc. All of that divided by 2. Once again, we're going to multiply both sides by 2 like this. So these are going to cancel out. So this is going to give me 108 is equal to 13x minus 6. Now don't forget to distribute this minus sign. So this is going to be minus 5x minus 14. So this will be 108. 13 minus 5, that's going to be 8. And negative 6 and negative 14, that's negative 20. So I'm going to go ahead and add 20 to both sides. So that's going to be 128 is equal to 8x. And just divide by 8. So that is 16. So x is 16. This is turning into the longest video ever. Oh my gosh. Okay. We are supposed to find all of these numbered angles. Look, just off the top of my head, let me just blurt out a couple things. You should always be on the lookout for straight lines. Anytime you have a straight line, straight angle, that is 180 degrees total. So whatever angle 1 and angle 2 turn out to be, for example, you can believe that I know that they will be a total of 180 degrees. They will be supplementary. So, you know, if angle 1 turns out to be 100, then angle 2 will be 80, for example. That's the same thing with what's happening right here with the VT. Okay? That is a straight line. That means these two angles have to add up to 180 degrees. Okay? So that means if angle 3 was 80, angle 4 would be 100, for example. So just keep that in mind as we do this problem. Now, let's see. Here's the one that I feel like doing first. Which one do I feel like doing first? I feel like finding, maybe I'll go in order just for the heck of it. Let's find the measure of angle 1. So, as I often do, I like to color things in to make it clear. So, angle 1 goes like this. Alright, let's draw it in green. So, angle 1, this is angle 1. Okay? Now, the arc that goes with that, the intercepted arc, if you will, is this arc that goes from one part of the angle all the way around to the other part. Notice that this arc is simply made up of 70 and 124. So all I really need to do is add 70 plus 124. And that is 194. So this red arc out here is 194. What we learned was this green angle is an inscribed angle. So it should be half of this arc. So I just need to do 194 divided by 2. So that's 97. So that is the measure of angle 1 is 97 degrees. I'll put it here in green for a minute. So this angle right here is 97 degrees. So let's keep track. I'll make a little list over here. We're supposed to find the measure of all the angles. So the measure of angle 1 is 97 degrees. Now, like I said right from the beginning, angle 1 and angle 2 are supplementary because of this whole being a straight line business. So angle 2, I should be able to just subtract from 180. So if I simply go 180 minus 97, that should give me the measure of angle 2. So that's 83 degrees. Okay, so this is 97 over there, but meanwhile, this is 83 degrees over here. If I add those up, I should get 180 because it makes a straight line. So the measure of angle 2 is 83 degrees. So the measure of angle 2 is 83 degrees. Now, the measure of angle 4. I'm going to start all over again for that. Now, when I look at angle 4, the vertex of angle 4 is here in the interior. All right, here's the vertex. But guess what? That is not necessarily the center of the circle. In fact, I know it's not the center. Otherwise, these two arcs would be the same. So look, this is not the center of the circle. In fact, I'm not even going to put a dot here because that's going to make it look like it's supposed to be the center. So this is what we're going to do. So we're supposed to find the measure of angle 4. And I'm going to go ahead and find that by using, let's see, I'm using this formula right here. Angle is equal to arc plus arc divided by 2. Okay, this is the situation we're in. Angle equals arc plus arc divided by 2. So,
I'm back, Mr. Brayton, you're going to kill yourself. It's so hot in here.
Stand by, stand by. The two arcs that we're dealing with are this arc right here and this arc right here. Okay? Those are the two arcs that we're dealing with when I say angle equals arc plus arc divided by 2. So can I go ahead and call angle 4? I'm going to call this theta because I do that all the time. So I'm going to go ahead and call this angle theta. Okay, so, alright, so that's angle theta right there. I mean, it's angle 4, but that's what we're supposed to find. So using this formula, that the angle is going to be the arc plus the arc divided by 2, you know, this formula right here, then it's going to look like this. That theta should equal 110 plus 124 divided by 2. So that is 117. So remember that's angle 4, so I'm going to go ahead and record that over here. So the measure of angle 4 is equal to 117 degrees. And again, looking at angle 3 and angle 4, can you see how they make a straight line? Okay, I'm talking about this right here. Let me do this in orange. Make it just slightly bigger. This is a straight line right here. So, how many degrees is a straight line, Daniel? 180 degrees. So if I take this straight line and I split it up into two pieces, those two pieces, the 4 and the 3, better add up to 180. So we just found that the angle 4 was 117. So the other one is going to be 63. Alright, because just subtract 180 minus 117. So angle 3 is going to be 63 degrees for that reason. Wait, I already forgot what it was. 63 degrees. And that's it. We found all of the numbered angles. Alright, this lesson is already like an hour long, so I'm going to stop it there. I'll see you on the next video. If this was helpful at all, please go ahead and give me that thumbs up. Hit the like button for me. I really appreciate it. Alright, I'll delete this part later. I'm just recording this part so the image will show up on YouTube. Like this will be the main image that shows up. So, ignore the fact that it's recording, is what I'm saying. These are the options. We've got tonight's homework. Do you want to work on that? Or do you want to go back and look at some of the old stuff we've been doing?
It's an extra work on like the stuff that we just did today.
Yeah.
I got that, so we'll go back.
Oh, you understand something?
Yeah, I understand like the x plus y.
And divide by 2. Okay. Okay. So when did I lose you?
You have a book?
It's good. Yeah. Do you have a book? Hold on. All right. Here are the lessons that we've been doing. Flip back through here. All right. I mean, this was like today's thing. Flip back until you find the stuff that you don't understand.
Is that like this whole thing?
Yeah, this takes us back to like day one. Like here's day one, all right, warm up. So you're holding everything we've done since Christmas. Did you get straight everything that you got wrong in the quiz?
Yeah, I knew what I got wrong.
You understand
Yeah.
all of that stuff for sure.
Yeah.
Okay.
Like I got these stuff right here.
All right, all right.
Number 4, 5.
Okay. All right, so this is back to this day one. All right. All right, well, let's start with that. Wait, put this back in. That's like the original. I'll go ahead and get a copy what you can mess with. All right, let's start with this.